Hello everyone. Today we will discuss a problem of the topic of rocket propulsion that we have discussed in the lecture number 2. And let's look at the problem. The problem says for a rocket, velocity of exhaust gas relative to the rocket is 2 km per second. Mass of the rocket is 1000 kg. What should be the rate of the fuel consumption in order to get launched with 4.9 meter per second square acceleration upward? So let's say the rate of fuel consumption is dm by dt. It is minus dm by dt because mass is always decreasing with respect to time. Now, if the rocket is expelling the gas with relative velocity of Vr downward direction, it will get a thrust in the upward direction. Now, what is the thrust? If it is consuming the fuel at the rate of dm by dt, the thrust it is going to get is thrust force dm by dt into Vr. Now, as it is getting launched with some acceleration of 4.9 meter per second square, it has to overcome the gravitational force or its weight. So, the net force upward will be equal to the thrust force generated due to the fuel consumption or fuel exhaust minus its own weight mg. That is the thrust force upward, and that net force is equal to mass at that instant in the acceleration. So we'll write it that mass into acceleration is equal to the thrust force dm by dt into Vr minus its weight. Now we know this Vr, the exhaust gas velocity, that is 2 km per second. Its weight 1000 kg into 10, that we already know. We have the value of the acceleration that it needs in the upward direction, and mass at that instant also we know 1000 kg. We'll just put those values. So 1000 into 4.9, that will be equal to of minus dm dt, that we have to find. Vr we already know, that is 2 km per second, so we'll write it as 2000 meter per second, minus mg is 1000 into 10. Okay, now everything is there. We'll just find out the value of the dm dt. Dm dt is 4900 plus 10,000 by 2000. So it is 14900 by 2000. So it is coming around 7.45 kg per second. So that is the required rate of the fuel consumption in order to get launched with this acceleration. I hope you have understood. Now I will extend the problem. Now we have found out the value of the fuel consumption required to get launched with this acceleration. That is 7.45 kg per second. That is dm by dt, minus dm dt equal to 7.45 kg per second. Now, the next question is, what will be the velocity of the rocket after 5 seconds of its launch? So, when t will be equal to 5 seconds, find out the velocity of the rocket. This is the part number 2 of the question I am extending. Okay. Now from the lecture number 2, you know the value of the velocity as a function of time. V equal to u minus gt plus Vr ln of m naught by m. So I have to find out the value of the velocity after 5 seconds. So here t equal to 5 only we will put. So what will be the value? V at t equal to 5, initial velocity is 0, minus value of g is 10 will take into 5, plus Vr, we already know that Vr value is given here 2000 meter per second, and ln log of initial mass, m naught is the initial mass here, Initial mass is 1000 kg. 1000. So it is consuming the fuel at the rate of 7.45 kg per second. So after 5 seconds, how much mass will be left? So 1000 minus, it has consumed how much mass in 5 seconds? 7.45 into 5. Right now this is the mass of the rocket, that is the m. Now it is just a simple calculation, that is minus 50 plus 2000 ln 1000 by this one, and the value of this 962.75, and it is minus 50 plus 2000, value of this is 0.03827, like that. And so it is becoming minus 50 plus multiplying this approximately 76.5. So the velocity is becoming, this minus this is 26.5 meter per second. So after 5 seconds of its launch, the velocity of the rocket will become 26.5 meter per second. I hope you have understood. Thanks for watching.